I'm Justin. I'm Matt.
I'm Hannah.
And we would like our introduction to speak for itself. As soon as it loads, it will speak for itself. Actually, it doesn't have audio, so we'll be singing the...
Use the audio?
No, we'll be singing the StarWars theme, so it's okay.
Okay.
Okay, so after that introduction, why did we choose Star Wars? Other than the possibility of making such an intro like that, we chose it because it plays such a large part in our childhood. So from Tatooine to Hoth, Kashyyyk to Endor, Coruscant to Yavin, the places that the Star Wars movies have taken us have impacted generations of moviegoers by inspiring us to dream of distant worlds and the futuristic technology that makes these unique characters' adventures possible. So these movies in particular have interested us in their use of the mathematics and physics. And these movies always leave us asking questions though, like, would Luke really have survived that fall? How much power does the Force have? Would they really have been able to make 1 million clones in only 10 years? And how exactly big is the Death Star?
The history of the Star Wars franchise, well, George Lucas was inspired by a lot of different things, but his main inspiration came from the Flash Gordon series from the 1930s. It's where he got the ideas for the Rebels versus Empire conflict, the Cloud City, and the iconic roll-up at the beginning of all of the films. He was also inspired by The Hidden Fortress and other Akira Kurosawa samurai films from the 1950s. Darth Vader's helmet resembles a samurai helmet, and the two bickering droids are very similar to two bickering peasants in one of the movies, and the queen who often trades places with her handmaiden, as well as as seen in the first movie. The Lord of the Rings trilogy also had some inspiration to him because of the characters of the very powerful, wise, light magic character in Gandalf and the dark, evil villain in Sauron that inspired Obi-Wan Kenobi and Darth Vader. He only intended to have one movie to start with, but then as his imagination kept growing, he created a story and determined that there would be 12. After 6 movies, he kind of gave up on trying to do all 12 of them, but still had the 3rd installment developed and thus passed the franchise on to Disney. The Star Wars franchise brought the revival of the space opera genre, which is like an over-romanticized space adventures with a lot of like chivalric themes and that whole good versus evil conflict. That includes the Battlestar Galactica, Ender's Game, and Guardians of the Galaxy.
Alright, so history of some of the calculus used in this presentation. We got Newton. So there's a lot of physics in Star Wars. So the velocity function is a derivative of the position function, so that's where that comes from. the fundamental theorem of calculus, the impulse equation that comes from Newton's second law, volume using anti-differentiation, and we have Leibniz, who developed the integral in differential calculus. Dx and dy is infinitely small distances between values and integral notation.
I think some would say their biggest competition was over calculus, but I think it actually was who could have it that way.
So we wanted to find the power that a lightsaber would have, and we chose an example from episode 1 of The Phantom Menace, where Qui-Gon Jinn melts through titanium blast doors with his lightsaber. So titanium has a melting point of 1,668 degrees Celsius, or 1,941.15 Kelvin. It has a specific heat of 0.54 joules per gram, and specific heat is the amount of energy needed to raise 1 unit of mass, 1 unit of temperature. And it also has a density of 4.43 grams per cubic centimeter. We estimated the doors to be about 4 by 2 by 1 meters titanium, and then we converted our measurements to other measurements that would fit the equation that we need for heat transfer, with Q being the heat transfer of mass times specific heat times the temperature change in Kelvin. And we plugged in our values that we found and determined that it would be about 31 billion watts, or 31,538 kilowatts of power needed to melt through those glass doors. And that would be enough power to power about 686 houses with air conditioning and appliances.
Keep in mind that he's holding this in his hands, and the blade starts right after the end of his hand. So I don't know what kind of gloves these Jedis are wearing, but
I'm pretty sure they would all spontaneously compress.
just a little bit, yeah.
We also wanted to find the area between 2 curves, and we used this to determine how many total attempted clones were created in episode 2, Attack of the Clones. So they created 1.2 million clones in 10 years, and so using secant line type math, we determined that that was about 329 clones per day, and we found a function for that. And using real statistics, it's about a 1 in 277 failure rate for each successful clone. So we found an equation for that in failed clones per day. So we multiplied the 277 times 329 and got an equation for that. And we subtracted the failed clones equation from the successful clones created, and created an integral for that, and determined that there would be over 331 million attempted clones created in those 10 years. And it's really interesting that even with only 1.2 million clones created successfully, the planet that they were created on is completely covered in water, and so they don't really have agricultural capacity. So they would have had to import 24 million tons of food for all of those clones.
Or eat a lot of sushi. This is also a pretty good estimate for the population of the United States at this time.
Alright, so in episode 3, spoiler alert, a lot of Jedi die. So we wanted to see what was the average rate of Jedi killed over the span of the 19 years. So between episode 3 and episode 4, it's been 19 years. So where these points come from, so 0 is the initial time when the Jedi Purge takes place, and the 10,000 Jedi is about an estimate of how many there are. In between 0 to 1 years, there's a 1% chance of survival, so that's where the 100 Jedi comes from. And these 2 points right here are a rough estimate of where it might be at that point in time. And at 19 years, there are 2 Jedi left, Obi-Wan and Yoda. So we took d of 19 minus d of 0 over 19, and that gives about 526 Jedi killed per year. And we also estimated the derivative of 0.5. So we did d of 1 minus d of 0 over 1, and that was about 9,900 deaths per year at 0.5 years, which makes sense for that 1% survival rate. And this math used can use to find change in a certain amount of time, and other examples include population, temperature, and snowfall.
Episode 4, A New Hope. So this was originally just called Star Wars because this was the first movie in the series, and then was later added New Hope as the sequels were created. So the Millennium Falcon, as seen here, is claimed to be the fastest ship in the galaxy, going 0.5 past light speed, which is kind of a ridiculous number because that would still take months to get them where they're going. So after fleeing the planet Tatooine, they jump into hyperspace and fly to the remnants of the planet Alderaan because, spoiler alert, it got blown up by the Death Star. So the estimated distance between Tatooine and Alderaan is 38,000 light years apart. And we also estimated the time that it took them to get there. So they traveled 38,000 light years in 13 hours, giving them a speed of 2,923 light years per hour. So we used the velocity equation and the position equation, and we integrated them. So the integral of the acceleration function is velocity. So when we solve for that, velocity equals the acceleration times the time plus c, where c is the initial velocity. We estimated c to be around 40,270 kilometers per hour, as that is the, to be around 40,270 kilometers per hour, as that is the escape velocity from Earth's atmosphere. So escape velocity is how fast you need to be going to completely break gravitational influences of Earth. So then I solved the position function for A. So the position function would be 1/2 a times t times squared plus initial velocity times time plus initial position. So when solved for A, it gives you 2 times the change in position, which is delta x there, minus velocity times time divided by time squared. So the change in position is same up here, or 38,000 light years. Here we just converted it to kilometers. V is initial velocity, which I explained to be 40,270 kilometers per hour. And 13 hours is the time of travel. So solving this equation, this gives us our acceleration to be, what number is that? Quadrillion? Yep, that's 4 quadrillion kilometers per hour cubed, which is equivalent to 1 quadrillion meters per second cubed, about. And at that point, it's kind of just ridiculous to imagine what forces this ship would be experiencing and the people inside it. So these formulas are used in all kinds of physics equations to model velocity, acceleration, and position. So basically, from throwing a tennis ball, launching a catapult, anything. Episode 5, The Empire Strikes Back. So in episode 5, Luke is battling Darth Vader after he reveals kind of a big secret to him. And Luke decides to jump from a parapet of sorts into a trash chute that falls down the bottom of Cloud City. So we found the time that he fell, which is 11.8 seconds. And we also calculated the gravity on Cloud City to be equal to the gravity on Earth. So we said gravitational acceleration. And then, so that would give us, using equation for final velocity, we found the final velocity that Luke was traveling to be negative 115.64 meters per second. And the initial velocity, since he fell from a resting position, would be 0. So the change in velocity would be that initial, or that final velocity, negative 115.64 meters per second. So now we used impulse, which is equivalent to the change in momentum. So now the change in momentum is also equivalent to a lot of other things, which is mass times change in velocity and force times change in time. So if we solve using the mass times change in velocity, Luke's mass is estimated to be 72.6 kilograms times negative 115.64 meters per second. So that gives us the impulse, which is 8,395.464. And then the unit for this is meter kilograms per second. So kind of weird when there's no other name for it, really. And we can also, since mass times the change in velocity is equal to force times the change in time, we can set that answer that we just got equal to force times the change in time. Now the change in time is estimated from Luke traveling negative 115 meters per second to when he stopped. So the impact was estimated to be 1.16 seconds. So the change in time is the time of impact. So force times the time of impact, which is 1.16 seconds. And then we divide that out from the answer that we previously got. And we got the force to be 7,237 newtons over 1.16 seconds, which is, that's a ridiculous amount. The force to break a bone is something like 900 newtons. 900 newtons over 0.2 seconds, something like that. So, I don't know, maybe he used the force or whatever, but physics is telling us he should be a little bit dead. Episode 5, The Empire Strikes Back. So we wanted to find the power that the force had. So the greatest example of power that we see in the series is when Yoda lifts an X-Wing, as seen here, out of a swamp. So we estimated the weight of the X-Wing to be approximately 6,507 kilograms. We estimated that using various fighter jets that are currently in operation around the world, and scaling them down to the size of an X-Wing. So we calculated the lifting speed using the estimated height of the X-Wing, which can be seen through people standing next to it and just estimating it. I believe it's estimated to be about 12 feet tall, or 4 meters, when the landing struts are down. So we calculated by watching the video a bunch of times how fast the X-Wing was being lifted. So it was being lifted about 0.179 meters per second for 7.82 seconds. So it was lifted 1.4 meters up. And the gravity on Dagobah is calculated to be, Dagobah is the planet where they are during this scene, by the way. The gravity on Dagobah is said to be 0.9 Gs. So 0.9 times the gravitational acceleration will give us the middle. And the equation used here is, what is it? It's mass times gravitational acceleration times time. So that's the simplest equation for watts, which is mass, or force over time. So the weight of the X-Wing times gravitational acceleration times 1.4 meters, that's the height that's lifted, divided by the time that it took, gives us 10,274 watts. And 10.2 watts can power a small household with AC and some small appliances. So maybe Yoda should give up his fighting evil and just like power my house a little bit.
Alright, so episode 6, Return of the Jedi. The Empire needs a new Death Star after the 4th movie, so we found that the diameter of the new Death Star is going to be about 160 kilometers, and then that would mean the radius is 80 kilometers. So then we did the equation of the circle.
Should be square root.
Yeah, square root of the
Right where the square is.
Yeah. So then we integrated that from negative 80 to 80, and then found that the answer would be about 31,582.734 kilometers cubed. And that's an overestimation at this time, because obviously seeing the picture, it's not complete yet.
So if you don't know the history of Star Wars, after the 4th movie, the rebels blew up the first Death Star. And in the 6th movie, the Empire is making another Death Star. I guess because 1 million casualty explosion wasn't enough. These are works cited. Many Bothans died because of this information.
All right.